Hey, how's everybody doing? This is Suzanne again for Suzanne's Tutoring. You are probably watching this on YouTube, where you can find my channel at YouTube/Suzanne's Tutoring. Don't forget to like and subscribe, and when you're looking for me, just look for the big red S.
Okay, so the first thing you need to know about organic chemistry is what the heck are those drawings? How to draw like that so you understand what's going on. Because half of chemistry is just deciphering the secret codes, the little abbreviations that scientists use when they write stuff down. It's not even figuring out how stuff works, it's just deciphering the abbreviations. So let's first start with the most often used drawings of chemical molecules with the line bond structure. And this is also called the skeletal structure. So if they say do a skeletal structure or line bond drawing of something, this is what they mean. And this is what you will normally see, with some exceptions, but this is what you normally are going to see and what you're normally going to work with in OChem. Refresh. So refresh. Let's talk about Lewis dot structures. Remember introductory chemistry, Lewis dot structures? So let's do this first one. We have CH4. You usually want to start with the carbon, or you can go left to right. But really, the reason why they say left to right is because they usually put carbon first. So you really just, especially in OChem, you want to pay attention to that carbon because the carbon is going to be the basis for every single thing that you do. It's all going to be about the carbon. So we have this one C and we have four H's, right? In this CH4 right here. So let's look at the periodic table. Here's carbon. And as you can see, carbon is part of group A. Group A are these two towers here. And if you don't remember, you can go back to my periodic table trends videos and watch that. But these two towers on the left and the right are both considered group A. So this is one group, 1A, 2A. You see how it's already written on there, 3A, 4A. So carbon is the fourth in line in group A on the top row. So carbon is going to be 4, and that's because it's number 4 in group A. It's the fourth column in group A. So what does that mean? So that means that carbon is going to have 4 electrons around it. And if you remember in drawing Lewis dot structures, you don't just go 1, 2, 3, 4, right? You do 1 on each side and then you go back around. So you go 1, 2, 3, 4. And then if there was more than 4, you go 5, 6, 7, 8, that type of thing. But we only have 4 for carbon. So carbon has 4 electrons around it, spaced 1 on each side. And then now let's look at the hydrogen. And so up here, hydrogen is in group A as well, and it's in column 1. So what does that mean again? Hydrogen only has 1 electron. So you're only going to draw 1 electron. So there's 1 carbon, so we're going to put that in the middle. And then there's 4 hydrogens. So we're going to make 1, 2, 3, 4 hydrogens on all 4 sides of the carbon because there's 4 of them. Now remember, the carbon has 4 electrons. 1, 2, 3, 4. And the hydrogen only has 1 electron each. 1, and then 1, and then 1, and then 1. Now, when the carbon and hydrogens bond, they're going to bond by connecting their electrons. So each bond has 2 electrons, 1 from the hydrogen and 1 from the carbon. So 1 bond means 2 electrons. So 1 from the carbon, 1 from the hydrogen. So 1 from the carbon, 1 from the hydrogen. 1 from the carbon, 1 from the hydrogen. 1 from the carbon, 1 from the hydrogen. So in a Lewis dot structure, you can either do the 2 electrons, 1 from the carbon, 1 from the hydrogen, next to each other like that, or you can expand that to be the actual bond between each of the atoms. So let's try this next one. C2H6. So the C2 means there's 2 carbons. So as I said, you always want to start with the carbons. And carbon has 4 electrons each, right? Let's do this over here too. 1 on each side, 4 electrons each. These carbons are going to bond together to make a little line of carbon-carbon. So we're going to do this with 1 each of the carbon's electrons, and that's going to be bound together. So now we have C2. It's 2 carbons. But now what are we going to do with these 6 hydrogens? Well, if you look, there are 1, 2, 3, 1, 2, 3 electrons left over on each of the carbons. And look at this, there's 6 hydrogens. So that makes 3 hydrogens on each of the carbons. And each hydrogen only has 1 electron, right? So we're going to connect the 3 hydrogens to this carbon over here, the 1 electron from the hydrogen bonding with 1 of the electrons from the carbon on every side, and same thing over here on this carbon. So let's do this third one right here. We have C3H8. So that means there's 3 carbons. And of course, each carbon gets 4 electrons, because remember, that's what we found out on the periodic table. If you look up and see what group it's in, 4A, that means 4 electrons each atom. All right, now we're going to connect these carbons together because this C3 means that's this chain of carbons right in a row, bam, 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 3 carbons. And since each carbon can connect with 1 of its electrons, we're going to connect 1 electron each. So the carbons are all connected to each other. So now we have this chain of 3 carbons in a row connected to each other. And now let's look at the hydrogens. We have 8 hydrogens. And each hydrogen has 1 electron, right? So it's going to form 1 bond with somebody. So we have hydrogen up here with an electron, and that electron is going to bond with one of the electrons from carbon. So we have this hydrogen bonded to carbon, and then we're going to do the same thing with the other hydrogens. We have a hydrogen over here bonded with one of the electrons from the carbon, and we have a hydrogen here with 1 electron, and that's going to bond to one of the electrons of the carbon. So now, as you can see, we have used up 3 hydrogens. Here's hydrogen 1, hydrogen 2, hydrogen 3. That's 3 of them on this carbon. We can't put any more hydrogens on this carbon because carbon only has 4 electrons. So that means 4 opportunities to form a bond with something. And so the other bond, the 4th bond, is the carbon bond to the next carbon. So we can only put 3 hydrogens on this. The same thing with the end carbon. On the end, way over here on the end, we have a hydrogen with 1 electron, a hydrogen, 1 electron, a hydrogen with 1 electron. And this hydrogen bonds with the carbon, this hydrogen bonds with the carbon, this hydrogen bonds with the carbon. So on this, we have one hydrogen, 2 hydrogens, 3 hydrogens on this 1 carbon. But even though carbon has 4 electrons, this 4th carbon is being bound to the central carbon. Now, we have on the one end, we have 1, 2, 3 hydrogens. And on the other end, we have 1, 2, 3 hydrogens. So that makes 6. So we have 8 though. So we have 2 left to go, right? Well, looky here. Look at the middle carbon. The middle carbon has 2 electrons left. So we're going to put 1 hydrogen on one side with its electron and 1 hydrogen on the other side with its electron. And we're going to draw the bonding lines between those electrons. So now we have 2 hydrogens on this central carbon. We have 3 hydrogens on each of the ends of this chain, this carbon chain. And then this middle carbon only has room for 2 hydrogens, 1 and 2, because the other 2 electrons that carbons have are bound to the other carbons in the chain. Let's do this last one, C4H10. So we have 4 carbons. So we're going to put those right in a row because carbons usually form in chains, especially in organic chemistry. Just go ahead and assume that the carbons are all right in a row. They form chains. So see, these carbons are all chained together. But remember, carbon has 4 electrons each. And what's going to bond to those electrons? Well, the hydrogen, of course, because that's what we have in the formula. And we have 10 hydrogens. So if you look at the ends, the end carbons on either side, here, let's do this end, and then there's this end. On either side of the chain, these carbons each have 3 electrons left, right? So we're going to put hydrogens bonded 1 to each of these carbons. And we're going to do the same thing on this end. All right, so now we have 1, 2, 3, 4, 5, 6 hydrogens, because 3 on each end. But we have 10 to go. We have 10 total. So 10 minus 6 is 4. So we got 4 left of hydrogens. Well, looky here. We got 1, 2, 3, 4 electrons on the carbons, and we have 4 hydrogens left. And so here is what you call a carbon backbone. When it's a chain of carbons, and then all the rest of the electrons for the carbons, all the other spaces where carbons need something to bind to it, are hydrogens. And if you notice, there's 3 on the ends. 1, 2, 3. 1, 2, 3. And then the middle carbons that are sandwiched in there, each has 2 hydrogens. So that is what is called a carbon backbone. And the reason why it's called a carbon backbone is because, as you'll see later, things can come off. Like we can replace one of these hydrogens, like with an oxygen and a hydrogen, hydroxy group, and things will come off of it, at different places. But the backbone, the chain of carbons, will remain the same. All right, now, so let's go back to this, the one with the most carbons, this C4H10. So what we did was we put 4 C's in a row, 4 carbons in a row, forming the skeleton, the backbone. And then coming off of each of those carbons were hydrogens, right? So, but look how long and annoying it's taking for me to draw this. I'm sure you're getting annoyed and trying to speed the playback up just to get out of having to watch me draw this over and over and over again, because it is long and annoying. And as I've said it before, I'll say it again. Scientists are lazy. And if we can get away with doing a shortcut and not writing everything out longhand, we will do it. So the way chemists are going to write this, because they're not going to take that much time writing this out every single time they got to write something like this out, because it's often, we're going to instead draw a little jagged, like saw edge, okay, like that. Not as messy though. So each carbon is going to be one point or one corner of this little up-down sawtooth shape. And I call it sawtooth because you know how like a big saw, you got the handle there, and then here's the blade, and the blade goes like that for some kinds of saws. So this jagged edge is literally called sawtooth. So that's what I'm saying. I'm saying the word sawtooth. So we're going to do 4 carbons. So that means we're going to have 1, 2, 3, 4. Oops, I put too many in there. Let's erase this. So if you start, when you're starting out, when you're a very, very beginner, I suggest doing the dots for each carbon. So 1, 2, 3, 4 carbons. Okay, so we got the 4 carbons. The hydrogens, what I was doing this, right, for the hydrogens. Okay, but good news, you don't have to do all of that. When you're drawing a carbon backbone like this, carbon, 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 and so you're doing it in this kind of sawtooth shape, it is automatically implied. It's assumed when you're looking at it that these hydrogens are going to be coming off of here, but they're just invisible. Nobody writes them down. So yes, in reality, there's going to be 3 hydrogens on each end, on each of the carbon ends of this carbon skeleton, this carbon backbone, and then each of these carbons in the middle are going to have 2, because they need a total of 4 bonds, right? So we got 1 bond here to the other carbons, and then we have hydrogen and hydrogen. You just automatically assume that in organic chemistry. So in order to write C4H10, all you do is this. So 1, 2, 3, 4 carbons. And you don't have to put the dots. I put the dots there for just so you can see what I'm talking about. But each of the corners, when it turns, and each of the ends, these are all carbons. Always. And if you don't have anything else coming off of these carbons, you are going to automatically assume that there are invisible hydrogens which make up for the total of 4 bonds that carbon needs. But this means 1, 2, 3, 4 means 4 carbons and 10 hydrogens. Just this right there. That's all you got to write for C4H10. Now, there is a formula that you can figure out like how many hydrogens something's going to have. Like if I say draw a skeletal structure of 4 carbons and just all hydrogens, just a carbon skeleton, okay, you're like, well, okay, 1, 2, 3, 4 carbons. But how many hydrogens is that? Well, you can draw it in yourself and count. You can go 1, 2, 3, and then there's 2 on this, and there's 2 on this, and 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 hydrogens. But you don't have to you don't have to go through that all the time, because some of these get really long. Right, so you don't want to have to sit there and count manually. So if you use however many carbons is N, so N is the number of carbons, which in this case is 4, you can use the formula 2N plus 2, and that's how many hydrogens. Because the plus 2 is for the ends. So you see how the middle carbon has 2 hydrogens connected to it, because on either side of the carbons, the other 2 bonds go to other carbons, right? So there's 2 hydrogens, so that's kind of the norm. So, but if we were to count, this is just 2 hydrogens, this is the end carbon, so we're going to be missing out on one of the hydrogens. And then the other end is going to have an extra hydrogen also. So that is the plus 2, okay, right there. So each sandwich carbon has 2 hydrogens to it, so that's the 2 of the 2N. And remember, the ends are the number of carbons, so it's going to be 4. And then we're just going to add, no matter how long the chain is, it's only going to have 2 ends, the beginning end and the end end. So no matter how long a chain is, it's just going to have the 1 extra hydrogen at the end and the 1 extra hydrogen at the beginning. So we're just going to add 2 to that. Now, another thing, they don't all the formulas, they don't look like this, right? They usually look like something like this, a little bit more complex, right? Well, I'm here to tell you the good news that this and this are the same thing. We have CH3 at the beginning. So you just go to the beginning of the carbon chain. And so here's the first carbon in the carbon chain. And how many hydrogens does it have? 1, 2, 3. So this beginning is CH3, okay? And then we have, going along the chain, we have the next carbon, and it just has the standard 2 hydrogens, and we have the next carbon, and it just has the standard 2 hydrogens. So that's going to be CH2. But there's 2 of them, right? There's a CH2 here, and there's a CH2 there. So we're just going to put that in parentheses so we can put a 2 outside of it to let you know there's 2 CH2s. There's a CH2, and there's a CH2. And then the ending is going to be another CH3, because it's the ending, so we have that extra hydrogen on there. So we're going to go CH3. So CH3, parentheses, CH2. So we can put 2 of them on the outside of that parentheses to let you know there's 2 of these CH2s, and then another CH3. And this is the same thing as C4H10. So this is how you are normally going to see the stuff written out. It's the same thing. These are all the same things. And that's the tricky part about organic chemistry and physics as well, is that there are like 5 million ways of writing the same thing. And you have to be familiar with all of them, just enough to be able to decode what the heck it is the scientist is trying to write down so you can understand it. Now, these hydrocarbons with just the carbons, carbon, 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 with just the carbons, and then just hydrogens filling up the rest of the bonds the carbons need. This is called an alkane group, alkane, when it's just a hydrocarbon. It's going to be all single bonds. See, these are all just single bonds. It's going to be a carbon chain. So see, carbon chain, carbon, 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 carbon. And then it's going to be hydrogens only making up the bonds with the carbons, besides the left and right carbons bonded to the next carbons. And all the bonds are going to be filled. So that means all the other bonds that need to be there for carbons are going to be hydrogens. And this is an alkane. Alkane. And you need to remember this, because this ane, this ane is how you're going to name other groups, or other molecules that resemble this. And I'll show you how. So in this alkane, this alkane is a hydrocarbon, right? Hydrocarbon. It's just a chain of carbons with hydrogens sticking out from the carbons to fill up, to make sure each carbon has all 4 bonds that it needs. So it's a hydrocarbon. It's called an alkane. So first you're going to number the carbons from end to end. So here we have 1 carbon, we have 2 carbons, 3 carbons, 4 carbons, 5 carbons. Okay, so we have 5 carbons in this chain. Now there is this, and you should get this in class. If not, you can copy this down. You need to just kind of memorize this. The number of carbons gives you whatever prefix it should have. So if there's only 1 carbon, the prefix is meth. If there's 2 carbons, the prefix is ep. If there's 3 carbons, the prefix is prop. 4 carbons, bute. 5 carbons, pent. So in this one, we have 5 carbons, right? So 1, 2, 3, 4, 5. 5 carbons. So that means pent is the prefix. So we just use the prefix plus the suffix from alkane, and that's it. So this is a pentane. Pentane is this structure right here. 5 carbons. Nothing else, just hydrogens to make up the bonds that the carbons need, and that's it. There's nothing else. There's no extra. There's no oxygen. There's no other molecules thrown, or no other atoms thrown in there. It's just 5, meaning pent, hydrocarbons, ane. Okay, so let's try this again. Here is another structure, and it just has that sawtooth structure to it, if you notice. Okay, so we count the carbons. Number the carbons from end to end. So that's 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons, 7 carbons. And of course, I shouldn't need to tell you by now that we just automatically assume that all of the rest of the bonds that carbon needs, because carbon always needs 4, right? All the rest of the bonds are invisible hydrogens coming off of the carbons. It's just not drawn in the skeletal structure, but these are invisible hydrogens. They do exist, and we always assume that they're there. So here's a hydrocarbon chain with 7 carbons. So C equals 7 at this point. And then remember our formula, 2n plus 2. So n is the 7. So that's 2 times n is 14 plus 2. That should be 16. And that's how many H's there are, right? So we got 1, 2, 3 at the end. At the other end, 4, 5, 6. And then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that is 16, just so you can get some more experience with that formula. So you can just do that really fast, and you'll know that this needs 16 hydrogens to make the hydrocarbon chain that we need for 7 carbons. So we're going to use this hept for 7 prefix. And then since this is all just a hydrocarbon chain with nothing else, and it's all single bonds, it's important, we're going to use this ane at the end. So hept and ane, heptane. So 1, 2, 3, 4, 5, 6, 7. A 7 carbon hydrochain is called heptane. Okay, so now we know that alkanes, alkane with A-N-E as the suffix, are hydrocarbon chains made of all single bonds. So like this. And there's those invisible hydrogens coming off of the carbons to make sure the carbon always has 4 bonds to it, right? But now what do we do when there's a double bond? It's not an alkane anymore. It's going to be an alkene, A-L-K-E-N-E instead of A-N-E. And that's going to be any hydrocarbon chain with a double bond in it. So like for instance, we have these 4 here. Let's do this top one first. You still want to number the carbons from end to end. That doesn't change. So 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons. And that 6 means hex, right? So we know the prefix is going to be hex. And since this has a double bond in it, it's not going to be hexane, it's going to be hexene. So hexene, it has 6 carbons and a double bond. Now, how do we indicate where this double bond is at in this carbon backbone? Well, we look at the numbered carbons, and as you can see, the double bond starts at carbon number 2, because it's always going to go up numerically. So when we write out this name hexene, we need to write the carbon number 2 in there to indicate what carbon the double bond that makes it ene starts at. So we can either write a 2 hyphen hexene, and we'll know that carbon number 2 is where that ene, that double bond, starts. Or sometimes you can write it like this. I prefer it this way. You can go hex and then 2 ene, because that puts the 2 right next to the ene. So it's very clear that carbon number 2 is where the double bond starts. Now let's take a look at this next one. So we have this double bond. So just like the 2 hexene or the hex 2 ene, however you want to write it. So what does that mean with this one down with the second one we're doing? Well, you always want to number the carbons. So whatever extra stuff is on this carbon backbone, in this case the double bond is the extra thing, you want to always number the carbons so it gives the extra stuff the lowest number possible. because it's always going to go up numerically. So if we were to number these carbons, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, well, then this would say that between carbon 4 and 5 is the double bond. But that's not the best arrangement to number these carbons, because that doesn't give the double bond the lowest possible number. What we want to do is we want to number it from the other end, 1, 2, 3, 4, 5, 6 carbons. See, it still has 6. It still has a total of 6 carbons. So it's still got that hex prefix. The double bond is going to start on the lowest number possible, on this 2, because it's always going to go up numerically. So see, if you look at the top one, we have this double bond starting at carbon 2, and on the second one, the double bond also starts at carbon 2. So it's just backwards, it's just reversed from the first one that we did. See, this is just backwards from the first one. So we don't need to number anything left to right. You don't have to worry about left to right. What you need to worry about is putting the lowest number possible where the extra stuff is going to be. In this case, the double bond. So this would still be hex 2-ene, because whether it's like this or like this, it's still, the double bond is still going to start on carbon number 2. Now, what do we do with this third one right here? Well, this third one has a double bond in the middle. So let's try numbering it from the left to right. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Notice how these are all the same length. They all have 6 carbons in them. It's just the placement of the double bond along this chain is what you need to pay attention to. So if we number it this left to right, 1, 2, 3, the double bond starts on carbon 3. So we could say that's 3-hexene. And remember the hexene because it's got a double bond in it. But what if we numbered those the opposite way? We started right to left. So this would be carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. So if we look at the way we numbered it this way, the double bond still starts on carbon number 3. It's just at the other end of the double bond. So see, this one has the double bond exactly in the middle of all the carbons. So it doesn't matter if you go 1, 2, 3, or if you go 1, 2, 3, the double bond still starts on the carbon 3. And so it's still going to be 3-hexene or hex 3-ene. So this isn't going to matter, but that's just because the double bond happens to be in the middle and it's symmetrical on either side. It has 2 carbons, 1, 2 carbons on either side of the double bond, 1, 2. Now let's take a look at this bottom one. Now this one has 2 double bonds, doesn't it? It has a double bond right here and it has a double bond right here. Well, so how are we going to name this? Well, easy enough. It's still going to have 6 carbons, right? Because it's still the same length as the other ones. So we're still going to be using the hex prefix. And just because it has 2 double bonds does not change the fact that we're going to use the "ene" suffix. "Ene" is for anything with some double bonds in it. It could be 2 double bonds, it could be 3 double bonds, it could be 1 double bond, it doesn't matter. And you don't put, it's not plural, it's not like, in English when something, there's more than one, you put an S at the end of it. You don't worry about that, it's just still hexene. But so how are we going to write down what numbers to put to mark where the double bonds start? Well, we do the same thing we've been doing before. We number the carbons from end to end. And we want to give pick whichever end we start with the number in 1 for the carbon that's going to give these bonds the lowest carbon number is possible. So if we go 1, 2, 3, 4, 5, 6, that means there's a double bond that starts at number 2, and there's a double bond that starts at number 4. So you go 2, 4, to let you know there's 2 of them, hex. And then since the "ene" means double bonds, but now there's 2 of them, we're going to put a little prefix di, meaning 2, in front of the "ene. So we'll go 2, 4, hyphen hex hyphen di-ene. And you don't put a hyphen in between the di and the ene. You just put them all together. So 2 double bonds, di-ene. Or you could always write it the other way. You can go hex and then 2, 4 hyphen di-ene. Just don't forget that in between the set of numbers and the words needs a hyphen. So there's going to be a hyphen in front of the numbers and after the numbers. But you do not hyphenate the di with the ene. You just put it all together, di-ene. So let's try one more of these. We have another carbon chain here, a hydrocarbon. I remember hydrocarbons just mean it's a carbon chain with hydrogens filling up all of the needed bonds that the carbon needs. So if we look at this hydrocarbon chain with double bonds in it, here's a double bond and here's a double bond. Now, if we number these carbons from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, we will have a double bond at carbon 4, starting at carbon 4, and we'll have a double bond starting at carbon 7. So that would be 4, 7 for the numbers to use for the name of this hydrocarbon. But is this the best way to number these? Because our first double bond starts on a 4, and then our second double bond starts on a 7. What if we numbered these going the other way, from the other end first? So that would mean this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, and carbon 9. So that means our first double bond is going to start at the 2, and our other double bond is going to start at the 5. So this arrangement, this numbering, is going to give you lower numbers for the double bond placement than the 4 and the 7, right? So this is the good one, smiley face. Now, how are we going to name these again? Well, we know that this has a total of 9 carbons in the chain. So we're going to look for the prefix for 9, which is known. So we're going to say 2, 5, hyphen, nonene. Ene for the double bonds. The 2 and the 5 tell us where those double bonds start. Or you can go known hyphen 2,5 hyphen ene. But wait, did I forget something? I sure did, because it's not just one double bond, it's two double bonds. So we need diene. So this would be known 2,5 diene. Or the way I did it up here, 2,5 known diene. And if there are three double bonds instead, there's another one here. Let's say this one starts at the carbon 7. We would have 2,5, 7 known triene. Known triene. So that would be three double bonds. Triene. The ene means double bond. The tri means three. So you are going to use these prefixes: di meaning 2, tri meaning 3, tetra meaning 4. Now, what if you have a triple bond? Well, triple bonds, when you draw triple bonds, instead of like with double bonds, I just went bloop, so it was just obvious that it's double. But in triple bonds, you don't turn the corner. Like here, you'd have a double bond there, so you turn the corner. But in triple bonds, let's say you have a triple bond between 3 and 4, carbon 3 and 4. So here's 3, here's 4. Okay, instead of drawing it like this, you would not turn the corners at the carbons that start and end with the triple bond. So you do like this: one carbon, and then here's two carbons, right? And then here's the third carbon, but then that turns into a triple bond, and then here's the fourth carbon, and that's a single bond, and then here's the fifth carbon, and then that goes up to the sixth carbon. You just iron it out. You just take this section with the triple bond in it, and you just iron it out so it doesn't turn the corner. So triple bonds just stay on the same plane as the before and after carbons. So a triple bond between 3 and 4 of a 6 carbon chain, because this would be carbon 1, carbon 2, here's carbon 3 where the triple bond starts, here's carbon 4 where the triple bond ends, and then carbon 5, you can turn the corner again, and carbon 6. So you only turn the corners when it's double or a single bond. If it's triple bond, you just don't turn the corners. You just keep it flat, the carbon's flat. And the ending of the triple bonds is ine, Y-N-E. So this would be called an alkyne. An alkyne is a hydrocarbon with a triple bond in it, alkyne. In this case, it has the 6 carbons, so we're still in the hex prefix, because hex stands for the 6 carbons, so hex is the prefix, but it has a triple bond. So the triple bond, we would give it an ine, a Y-N-E suffix. So hexine. And since we need to, when we're writing this down, we need to say where that triple bond takes place in the molecule. And it starts at the third carbon. So we're going to write down 3, a little hyphen, hexine, or you can write down hex 3-ine to mark that the triple bond, the ine part, the Y-N-E part, the triple bond, starts at carbon 3. And we just know it only goes to the next carbon, so it goes to carbon 4. It's not like there's a triple bond going from carbon 3 to carbon 5. It's only going to go to the next carbon. So we just automatically know it. So you don't have to say 3 to 4 ine. You know, you just go 3, where the starting carbon is, where that triple bond starts. So here are some more examples. So we have 5 carbons. So there's 5 carbons. They're all single bonds. See, just the one line in between, single bonds. So that means it's an alkane. And since there's 5, we're going to put that pent prefix in front, meaning 5. And then put the ane as the suffix at the end from alkane. So we're going to go pentane, pentane. Now here's a double bond. There's still 5 carbons, so it's still pent, right? But there's a double bond, so we know we're going to go with ene. The ene's from that double bond, because it's an alkene is a hydrocarbon with a double bond in it. And this starts on carbon number 2. So we're going to want to go pent 2-ene, or you can just say 2-pentene. Same diff. Okay, here's a triple bond. We still just have 5. We still have 5 carbons, so it's still pent. The only time you change this prefix is the total number of carbons, or what's going to give you that prefix. So it's still pent, but it's going to have a triple bond in it. So that means ine. It's going to end in ine, Y-N-E. And the triple bond starts at 2. So we're going to go 2-pentine, or we can go pent 2-ine. Either way is fine. You're going to see this written. Now, it's sometimes your teacher wants you to write it a certain way, but you're going to see it written in these different ways. And I just want to show you the different ways that different scientists write it and different textbooks write it, so you know that they mean it's the same thing. Okay, so when we were just doing the names, naming these molecules, I bet you might have noticed that I had the actual formulas right next to them, and they may or may not have made that much sense to you. So we're just going to go over this really quickly, because this is very important that you're able to read this stuff. So we have 2 condensed structural formulas. There's 2 different types. There's grouped condensed, and there's the expanded condensed. The expanded condensed is the very basic one, where in the case of this molecule right here, we have, you know, a carbon and a carbon and a carbon and a carbon and a carbon. And we know that there are invisible hydrogens coming out of each of these carbons. So carbon always has 4 bonds, right? Oh, I didn't give myself much room there. So here are the invisible hydrogens that we don't normally write in these skeletal structures. But let's look at this first one. Let's look at the very beginning of the left-hand side of this skeletal structure. This left-hand side has a carbon with 3 hydrogens attached to it, because that fourth bond the carbon needs is attached to the next carbon, right? So we're not going to worry about that next carbon. We're just looking at what is going on with this first carbon right here. So this is going to be CH3, right? Okay, so we're going to write down CH3. Then the next carbon in the chain, we just go to carbon number 2, right up here. This carbon is going to have a bond to its left to the previous carbon and a bond to its right to the next carbon. So it only needs 2 bonds filled to get its total 4 bonds. So there's only going to be 2 hydrogens bonded to this carbon. So we're going to write CH2. Then the next carbon, carbon number 3 down here, also is a sandwich carbon. It's got a carbon to the left and a carbon to the right. So it's only going to need 2 hydrogens to complete those 4 bonds the carbon needs. So that's another CH2. So we're going to go CH2 again. Now we're going to go to the next carbon. Next carbon, same thing. It's a sandwich carbon surrounded by, it has got carbon on the left, carbon on the right. So it only needs 2 hydrogens to make up the third and fourth bonds that the carbon needs. So that's another CH2. And then finally at the end, we have another CH3 because this carbon is only bonded to the carbon that comes before it. So it's going to need 3 hydrogens to make up the 4 bonds that it needs. So this is going to be CH3. So this is expanded condensed. Expanded, just think long. Okay, there is a shorter way to write this. And if you see the beginning of this expanded condensed formula starts with just one CH3 because that's the end, right? So one CH3 at the beginning. So we're going to write down CH3 like usual. But then look at this. We have 1, 2, 3 sandwich carbons that only have 2 hydrogens each instead of 3. So instead of writing CH2, 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 we're going to just put that in parentheses, CH2. And outside of the parentheses, here's 1, here's 2, here's 3 of them. So outside of the parentheses, we're going to put 3 down there to let us know that there are 3 CH2s right in a row. Then the very ending ends off with another CH3. So we're going to put that CH3 at the end right there. So this is the grouped condensed, group, think short, as opposed to the expanded condensed, which is longer. You're writing every single carbon out and what the carbon's doing. Okay, now here's a tricky one. Now this has a double bond in it, right? Here's a double bond right here. So we're going to start. Now remember, we have to number these, so the double bond or whatever extra this skeleton has gets the lowest number. So in this case, carbon number 1 is going to be here, so the double bond can start at carbon 2, and then 3, 4, so on, up to 5. Now let's think about the hidden hydrogens that are going to be in this structure. Now carbon number 1, that's the end carbon, and it only has 1 bond going to the following carbon, carbon number 2. So it's going to need 3 hydrogens to complete all 4 bonds that the carbon needs, right? So that's still going to be CH3. But let's look at carbon number 2 now. Carbon number 2 has a bond going to the left, to the previous carbon, and a bond going to the right, to the next carbon. But it's not going to have 2 hydrogens on it like normal sandwich carbons. Why is that? Because we're going to count each of these lines as a bond. So this carbon already has 1 bond, 2 bonds, 3 bonds. So this carbon already has 3 bonds connected to it. So in order to just get the 4th bond that it needs, it's only going to need 1 hydrogen. So there's only going to be 1 hydrogen coming off of there. So that is going to be just plain old CH, because there's only 1 hydrogen. And then the next carbon, carbon number 3, is in the same deal. It has a bond to the right of it, to the next carbon, but its bond to the previous carbon, there's 2 bonds because it's double bond. So here's 1 bond, here's 2 bonds, and here's 3 bonds because of the double bond. So the carbon already has 3 total bonds to it, so it's only going to need 1 hydrogen coming off of it. So that's going to be another CH. Now this next carbon, carbon number 4, has a bond from the previous carbon, that's 1, and a bond to the next carbon, that's 2. So if it needs 4 bonds total, it's going to need 2 hydrogens to make up those extra 2 bonds, those additional 2 bonds. So the carbon has 4 bonds. So this is going to be CH2. And then finally, at the end, carbon number 5 only has 1 bond connected to the previous carbon. So that means it needs 3 hydrogens to cap it off. So it has all 4 bonds. So there's another CH3. And you can also, there's another way to write this. You can also do the CH3 for the beginning, and then the second carbon is CH. And then you can do a double bond sign to the next CH. So we know there's a double bond there. And then CH2 for that sandwich carbon, and then the CH3 at the end. So this will let you know that there's a double bond. But even if this sign is not in there, if it's just what I first did, you can still figure it out. Because if there's a CH here, and there's only a CH here, then you know that there's going to be a bond somewhere in here that's going to make up for the lack of the second hydrogens. So you know that's going to be a double bond between these two. Now to write it in grouped condensed, we're going to do CH3. And then we have just CH. And we have another CH. So we can put those in parentheses and just go CH. And there's two of them. So outside the parentheses, you want to go 2. And then the next carbon has 2 CHs to it. So we can go CH2. And then the end carbon has 3 hydrogens, so we can go CH3. Now, you're going to have to think about this in the same way when we do triple bonds, because let's say this is carbon 1, this is carbon 2, this is carbon 3, 4, and 5. But how many hydrogens are coming off of each of these carbons? Well, we can start with the beginning, carbon number 1. It only has 1 bond to the next carbon following it, so it's going to need its standard 3 H's. So that's CH3. But then this next carbon, carbon number 2, how many hydrogens is that carbon going to need to complete its 4 bonds? Well, it's got 1 bond already to the beginning carbon, and then to the next carbon, it's got 1, 2, 3 bonds because it's a triple bond. So 1, 2, 3 plus 1 on the left, that's already equals 4. So this does not get any hydrogens. So it's just going to be a plain old C. C. And we can make the little triple bond icon there. And this carbon number 3 is going to be in the same deal because it has 1 bond going to the next carbon and it has 3 bonds coming from the previous carbon. So that's already 4. So that gets no hydrogens. So that's going to be just another plain old C. And then the next following carbon, carbon number 4, is going to have 1 bond coming from the previous carbon and 1 bond going to the end carbon. And that's it, just to the 2. So it's going to need 2 hydrogens coming off of it. So it always has a total of 4 bonds. So that's going to be CH2. And then finally, the ending carbon only has that 1 carbon from the previous carbon bonded to it, so it's going to need all 3 hydrogens for the end to cap it off. So that's going to be CH3. But we could also write it, here's CH3 at the beginning, and then we have just a C and then another C, so we can put that C in parentheses and just make a little 2 outside of it to let us know there's 2 C's next to each other. And then the next carbon number 4 is a sandwich carbon, so it needs both hydrogens, so that's going to be CH2. And then the end carbon is going to have all 3 hydrogens attached to it, CH3. So now don't get confused with just CH in parentheses with a 2 outside of it versus a whole CH2. Because CH2 means there's a carbon with 2 hydrogens coming off of it. A CH means there's a carbon with 1 hydrogen come off of it. And the 2 outside of the parentheses means there's 2 of those. So there's 2 C's with 1 H each. So don't get confused the number outside of parentheses versus a number inside the parentheses.
I am now available on YouTube and on my website at Suzanne'sTutoring.com. You're getting some free study tips, the free PDF downloads, free tutorial playlists, and there are never any ads, there are never any fees, there are no memberships to sign up for, there are no forms to fill out. No kidding. I don't ask for your personal information at all because it's none of my business.